Okay, so here's our problem. We gotta draw a free body diagram. Okay, I have everybody's attention up here, please. Okay, so the diagram. So here's the object. Okay, what's a force acting and in what direction?
Just 40 and 5.1.
Okay, so I heard gravity down, and I heard a force to the right, but I'm not going to put the number in there. What can I call it, maybe?
T.
No.
F, T, something. T.
Who knows? I mean, well, but if we're,
F's,
okay, it could be T. Maybe I'm dragging it with a rope. That's fine. I'm just going to, being as I already wrote the F, I'm just going to call it F sub P for like push force, whatever you want to call it. Doesn't matter. But give it a symbol so you know what it means. What else is acting?
frictional force.
Okay, in what direction does friction always act?
Opposite to the horizontal.
Opposite the direction of motion. And maybe it's even a good idea up here to kind of give yourself an idea, draw a little arrow so you know what direction is this thing moving in, right? Okay, so if it's moving in that direction, then we've got a kinetic frictional force because it's sliding, acting to the left. Anything else we need?
We got the normal force.
Okay, good. We have to have a normal force, right? And do you see that if we didn't have that, in what direction would the net force be acting here?
Down.
Strongly down, right? And so the sled would be burrowing into the ground at this point at 9.8 meters per second squared. That's not happening, right? It's staying on the surface of the ground. So there must be some normal force. The ground must be pushing perpendicular to the surface of the ground upward to prevent it from going through the ground, right? So that's F sub n, that's our normal force, right? Okay, this free body diagram gives you everything. You gotta draw this and you gotta know how to use it. So I'm gonna color code this right now. Let's make the horizontal forces blue and the vertical forces red. Okay, let's do, being as we're trying to solve for coefficient of friction, right? That's a frictional thing, correct? Okay, so let's go ahead and do the horizontal. Let's take care of the horizontal forces first. So the horizontal net force, I don't even have to write that down, honestly. I'm just reminding myself, what am I adding up here? But the important stuff starts in dark blue. Let's just add up all of the horizontal forces because that's the definition of the net force, right? The net force is the net horizontal force is just the sum of all the horizontal forces. What do they add up to, right? What are they?
F sub P.
Okay, so in the positive direction, we've got F sub P
Minus.
because it's going backwards, right? It's resisting us, so it's going to be negative F sub K. That's it. That represents right there, that is the net force because I added them all up, right? What is the net force always equal to by Newton's second law?
Mass times acceleration.
Good, so it's going to equal mass times acceleration, and really it's the acceleration in the horizontal direction. But there is no vertical acceleration, right? So we don't really have to write that little x. So I made it in light blue because it's just incidental. We don't have to put it there. Only the dark blue stuff needs to be there, right? Make sense? Okay? So now let's look at, so there's one equation of motion, right? That's what we mean by an equation of motion. We're just going to write down Newton's second law, meaning the sum of all the forces acting in that particular direction, right, horizontal, equal to mass times the acceleration in that particular, along that line. Okay, does that make sense? So the other one then is going to be, let's see, what I really need here, I really need like a light red color, don't I? Let me just do that real quick. I never use that one, so let's go ahead and pick like that. That's a good one, okay? Here we go. Okay, so now red. The light red is not necessary. It's just there kind of for our purposes to remind us what we're doing. So now the net Y force is going to equal, dark red stuff is important. So what forces constitute or make up, add to make the net force? Okay, the positive one is up is positive, right? So, and we might even want to do this, right? Like let ourselves know what's our convention for directions, but we don't have to because it's just the normal one. Right is positive and up is positive. So normal force is the positive one minus mg, okay? And that's going to equal what? 0, which is technically, so this is light red, we don't need this. That's technically equal to m times a sub y, but a sub y is just 0, right? So we don't have to write that. So these are the important equations right here. Oops. Okay, so good. But we want to find the coefficient of friction, and so we need some other supporting, we need to be able to write what the friction is, kinetic friction is in terms of its ingredients, right? We have an equation for that. Our model is right there, right? So we know that technically kinetic friction is equal to the coefficient of kinetic friction times what? Normal force, right? So we can make that substitution, right? Does that make sense? But then we need to know what normal force is. So where do we get that? Because really what we're trying to do is we're going to make that substitution up here, right? Okay, so we could take the blue equation, and the blue equation is now going to become, if we use that model, it's going to become F sub P minus mu sub K times normal force equals MA, okay? Right?
Would you put the mu in normal force in parentheses because some property doesn't come out because of PEMDAS?
Oh, it doesn't matter. Doesn't matter. You don't need to. Yeah, because of PEMDAS it won't matter. So what do we know here? We know that. That's good. We know, we're trying to find that, aren't we? Trying to find mu. We know M, we know A, but what's normal force?
After the equals, it's just mg.
Okay, from here, right? See, we can use the other equation of motion to be able to make a substitution because normal force is not given to us, right? Or it's not something that we have information to directly calculate. But if I take this red equation of motion and I add mg to the other side, look what I get. Normal force equals mg. So all I have to do is make that substitution, and I'm there, right? Now I've got an equation written with only one unknown, which is the thing I'm trying to find, right? Does that make sense? So then this becomes, when we combine all this stuff now, we get F sub P minus mu sub K times mg equals ma, right? Everybody agree? So I'm trying to solve for mu, so what would I do to get the mu by itself? Yeah, I'll tell you what I would do.
You would add mu.
I would add that to the other, I would exchange those two, right? So let's take this thing and add it to this side to make it positive and run that over there. Does that make sense? So we get F sub P minus MA equals mu mg, right? If I add mu mg to both sides to cancel that, and I subtract MA to cancel that.
Oh, so mu mg is basically like its own.
Well, that was a term, right? That's a term in this equation.
Oh,
Right.
But it's all its one term.
Yeah, it is, right? Because it's three factors multiplied together, but it's one term. You can think of it as being its own quantity.
Added the mu to the other side, like he added mu to both sides, right? So it canceled that on the left side, put it on the right side, and they subtracted mass and acceleration from both sides. So put it on the left side, and cancel that.
I did this. I added mu mg to both sides. And I subtracted ma from both sides. Right? So those cancel and those cancel, right? Now the alternative would be, and what you're probably used to doing would be to just say, okay, let's just subtract f and then divide by mg, but then I gotta change the sign, right? See that? It's really easier, in my opinion, to just move terms around in an equation than it is to be doing all that dividing and multiplying,
So,
right?
do you need unit itself, or is it already?
No, we gotta get it by itself. So what's the last thing we have to do?
Divide by mg.
Yeah, gotta divide both sides by mg, and then we got it, right? So now I just plug and check. I got everything that I need, right? See that process? I know it probably seems like a lot, but it's really not. There's not that much there. What did we do? We write out our equations of motion, right? Those are important. Those are the things we're gonna use to be able to make substitutions and plug stuff in for things I don't know, right? And then the only other thing we had to do was we had to, when we saw that we had a frictional force in there, we knew that we had to use the frictional force equation, right? Yeah.
So how do we know acceleration?
Acceleration's given to us.
Zero.
Is it zero the whole time?
Is it?
Constant velocity.
Oh, constant velocity, yeah, so the acceleration was zero. We could have said that was zero from the very beginning, made things a lot easier, right?
Yeah, but we can use all that for
Right?
Yeah.
So, I mean, we didn't even need to do all that stuff. It would have even been easier, right? It's still gonna work because now we'll just plug in zero for,
So it's just the
MA.
push divided by the,
yeah, so it's the push divided by the weight is equal to the coefficient of friction. That's it.
That's a lot easier, but
That
yeah.
literally takes like tossing a calculator.
Yeah, okay, but a lot of times in
But it's the
hindsight,
process,
things
yeah.
look pretty simple, but you will get some intuition about that. Really what it means when you're pushing on something,
Divided by weight equals
yeah, that's really all it's gonna be,
Here, could you scroll up real quick?
Acceleration equals zero.
No, push divided by weight.
right?
Oh, equals mu.
Or if you,
Mu.
Okay.
You said mu. So when we have mg, so it gives us the mass, so do we multiply the mass by gravity? Or is
Yeah,
mg,
yeah, okay.
is mg the mass what it gives us?
No, listen, here's another thing that I see people doing a lot, and this is probably partly my fault for just not, reinforcing this more, but, we suppress units a lot, right? But what is the unit of a force always gonna be? Newtons. Could it be kilograms? No, if something is measured in kilograms, it's a mass. That's fundamentally different than a force. If we're measuring, like an acceleration is measured in meters per second squared, that is not newtons, right? So the only things that you can add to a free body diagram here are what? Can I add accelerations in there? No. Can I add masses in there? Not by themselves. They have to all be forces, right? mg really is equal to what? We see that a lot because it's the force of gravity, it's weight, right? Weight is always equal to mg. So m times g is a force, right? M by itself is not, g by itself is not, but m times g equals weight. That's what in the book they call F sub g. So we can skip that step. I mean, weight is always mg.
So in this problem, you have your weight at 7.03, so would I have to times that by
That's not the
9?
weight. That's not the weight. That's the mass.
That's the mass.
Because that's
So I would-
measured
I
in
would have to
kilograms.
times multiply that by 9.8.
Yes,
to
you'd
get-
have to convert that to a weight.
Okay.
Right. Okay. Do we want to do the car one also?
Yes.
Okay.
Or you could just explain to me how you get the
So what unit
F sub P when you give me
Okay. Well, let's
Do unit
look at the car one. I think that's a good idea.
Okay, so this is, so you can leave all that.
How about this one? Okay, let's do this one. Thing is, this is very similar to the last one we just did. Let's do this one.
Is,
Okay, let's take this step by step. You guys draw the free body diagram, please.
what's the units of the coefficient of friction?
Okay, good question. Everybody listen to that question. That's an excellent question. There are no units.
Perfect.
That's what a coefficient means. Okay, a coefficient, in physics, that's what a coefficient means. A coefficient is a unitless number that you multiply something by, right? So, does that make sense? So what it does is it kind of weights or de-weights something based on what the value is, right? So, think about what friction's doing. Friction is the coefficient of friction times the normal force, right? So how strongly is the ground pushing up? Usually if we're pushing horizontally, it's just the weight of the object, right, to make things simple. So essentially it's saying what percentage of the object's weight is going to be invested in preventing it from moving, right? If it's very slippery, not very much, right? If it's not very slippery, only a little small percentage of the unit's weight is actually going to be used against you as friction. But if it's a rough surface, then a lot of its weight is going to, if it's 1, if the coefficient is 1, then it would be equal to the object's weight, the amount of pushing force that would be required to break it free, or to slide it if it's kinetic friction, right? Does that make sense? Yeah. And if it's greater than 1, which is unusual, that would mean it's cheating in some way. Either it's got some adhesion, or it's a surface like gummy rubber that's kind of actually molding to the other surface, and so it actually takes more force to push it than it would just to lift it up. Okay. All right, so draw the free body diagram. Copy down the problem real quick. So you don't have to look up here, and then I'm going to draw the free body diagram, but don't cheat and look until you've got yours drawn. Everybody get that? Okay, good. All right, so let's write down the equations of motion. Now, personally, I like to do the vertical one first, because just having done this stuff a lot, to me, I like to have that one there, because almost always, if there's friction, you're going to need to use normal force,
Would
right?
we be able to have the equations, force equations up there?
Yeah, that's fine. I don't care. That's fine. So, light red. The net horizontal force is equal to what?
The net horizontal force is FP minus FK.
Oh, oops, I did the wrong. Vertical force, sorry.
Oh, vertical force, normal force minus MG.
Yeah. Good. So vertical force is going to be, so that's sub y, is normal force minus mg. And what's that going to be equal to? 0, because there is no net vertical force. The object doesn't accelerate vertically, right? Okay, what about the net horizontal force?
Push force minus FK.
Right? And what's that equal to? MA. Good. So we're trying to solve. No, God, take me easy. So if we're trying to solve for A, then what's the only thing we got to do here to get the A by itself? Divide by M. Okay, so then the second equation of motion is going to give us this, right? We're going to get F sub P minus anything that we don't know. I'm going to write in orange if we don't know it, right? But we don't know friction, do we? Everything else is known, right? Okay, but we don't know the frictional force as a
But we
whole,
know the
right?
equation.
So that means we gotta do something. We've gotta be able to plug something in there that we know, right? So what do? Well, we write out the equation, right, for friction,
Yep.
which we know. We know that kinetic friction is equal to mu, which we know, right, sub k, times normal force, which we don't know yet, right? So we could make that substitution, couldn't we, right? I'm gonna go ahead and write this out as steps, although you could combine steps here. I think this might be easier to see. So then we could tweak this very slightly. So there was our first iteration. Now we're gonna set this equal to step number 2, where we've got f sub p minus that now, right? We're gonna make this substitution. Everybody see that? So we're gonna make this substitution right there. Minus mu sub k times normal force over m. That's unknown. Where do we get that?
Hold on, we threw that in, okay.
Right, because we always know friction just equals mu times normal force,
Yeah,
right?
but we know normal force equals mg.
Okay, from equation 1, right? From equation 1,
So we know that.
we get normal force equals mg, so we can make that substitution, and then everything would be known, right? Does that make sense? Right? Everybody see that? I mean, this is just solving, all we did was our second equation of motion, if we solve for A algebraically, we get this, but we don't know the frictional force. So we know that by definition, that equals mu times normal force. But to find out what normal force is, we gotta go back to equation 1. And then finally, what we get is, when we make that substitution, we get acceleration equals f sub p, which is known, minus mu sub k, which is known, times mg, which is known, over m. And then I just plug and chug, right? How do you make the and sign? Like that? I don't know. Anyway.
What's u sub k?
What's that?
What's u sub k?
Mu sub k, so if you, well, look, everything's up here. There's mu sub k,
Oh, okay.
right? There's m,
We just don't know.
there's push force.
Yeah.
That's all we need, right? To solve for A. Okay? That's a lot of stuff. I mean, that really is. This is more calculations than probably most high school physics classes are gonna do, but this is the stuff that's important. The other stuff's just extra. It's fun, but it's just facts. This is the stuff you gotta be able to do, actually do physics. So I don't mind spending more time on this. If everybody gets to a point where they can do some problems like this, then that's well worth it, right? But the only way to get this now, the only way is to just do these problems and then do them over again if you need to. But just get to a point where you can go through that process and get to an answer. But I think you're getting to a point now where the pieces you're getting good enough at, that now it's just a matter of kind of pulling all this stuff together into a process, right? It's impossible at first to do the whole process realistically, just because there's so many new things. But now, the individual pieces of this process, we've done quite a few times, right? So now you just gotta bring it together, okay? Make sense? Okay, I'm at it.